a circuit in terms of DC elements. And in today's video, I'm gonna solve a problem for you. You can see the circuit in the left hand side. This is the exact same circuit that I used to teach you how to do DC analyze. And I just add some value to the elements such as resistor and capacitor. But we're not going to need capacitor because we're not doing AC analyze, we're doing DC analyze. So all we need is a resistor and transistors. So let's get it started. As I told you before, first thing to do DC analyze is to find entrance loop. What's entrance loop? Is the loop that involves the voltage between base and emitter. As you can see my mouse pointer right here. Here is base and here is emitter. So this path will involve this one. Let me draw it for you. As you can see, it comes from right here, goes up, involving base emitter and going down again. So we can simply write the KVL in this loop. As you can see, this is it. This is the value of the voltage of this resistor. It's the value of the resistor itself divided by the value of all other resistors multiplied to their voltage source, which is VCC right here. This is 12. This is all equal to what? To the voltage of base emitter, and as I told you before, it's approximately 6 or 7 tenths. And as you can see, it's 6s right here. And one more thing, the voltage of this resistor, which is right here, the current that comes into it, multiplied to the value of the resistor itself. We can simply calculate the value of the collector current because this is the only unknown thing we have in our equation. As you can see, the value of the current collector current is right here. So what's next? Next thing is exit loop. What was exit loop? The loop that involves the voltage of collector and emitter. Let me show you. Collector is right here and emitter is right here. So the loop that involves these two things, or the voltage between them, is right here, coming from top all the way to down. So what do we have in our loop? We have VCC is 12 equal to what? To the voltage of these two resistors. And as I told you before, emitter current and collector current are the exact same thing. They're not exactly exact, but they have pretty much the same value, almost same value. So this is our voltage plus the voltage of collector and emitter. As you can see, it's right here. We have calculated the value of collector current in this equation, so we can put it into it and then calculate the value of collector emitter voltage. As you can see, it's right here. So let's go into solving another problem. So this is our circuit. We're going to analyze this circuit in terms of DC. There are 2 points about this circuit. First one, this transistor is not NPN. NPN transistor was the kind of transistor that it was like this. The arrow was from transistor towards emitter. But PNP, it's different. The arrow is from emitter towards transistor, as you can see right here. So what are we going to do? We're going to do the exact same thing that we have done to previous circuit. But here comes the second point. Second point is we don't need to calculate the value of collector current because we already have it. This is right here. As you can see, this DC current source is 2 milliamp hour. So this is our emitter current, which is equal to collector current as well. So we already have the value of collector current. As you can see right here is 2 milliamp hour. So all we need is exit loop in order to determine the voltage of collector emitter. But let me tell you, voltage of collector emitter is negative here because, let me show you why. Here is emitter and here is collector. If we're going through this path, the voltage of collector emitter will be positive, but if we come through this path from top to bottom, the voltage will be in first one, this is first one, the voltage will be negative because our current is coming through this path. You get it? Alright, so let's write the KVL. We're coming from top to bottom. What do we have? We have the value of voltage between emitter and collector, it's right here, plus the voltage of this resistor, which is its current multiplied to the value of itself. And we have -6, and this is our VCC. So here's the equation. We have the value of the collector current. We put this one into our equation, and we can simply calculate the value of voltage of emitter and collector. So that's pretty much it. Thanks for watching. See you next time.